Is it working? Am I live?
Yeah, you're live.
Okay, so this is a ammeter, and well, we're just waiting for our lunch in Iceland. I asked you earlier if you've got any questions about Iceland, then just ask, okay? Put them in the comments below. But I like this because, come a bit closer please, camera person, because this is a ammeter, but it's really exposed the workings of it. And the essential part of anything we use to measure any electrical quantity is a galvanometer. You can really see the galvanometer there really well. You see that spiral of like wire, basically. It's a coil of wire that's a spring. And when a current flows through that, it kind of attracts itself, and the coil will come closer together. And that is the only way we can actually measure any kind of electrical property. And that's hooked up in such a way as this reads out what the current is. But that galvanometer, it's important to understand, is the essential part of a voltmeter as well. And I really like this because it's an example of why essential part of a voltmeter as well. And I really like this because it's an example of why we have SI quantities. Okay, they are mass. I'm going to forget some: mass, length, current, and temperature. And there's one more. Oh, time. Yeah. And it has to be current because current is something we can measure directly, right? So all of those 5 SI quantities are things that we have ways to measure directly. We can measure length directly, we can measure time directly. We can't measure voltage directly, so that's not a SI base quantity. It's an SI derived quantity. So good stuff, eh? So as we've been traveling around Iceland, we've found so much physics going on. We've found, refraction when we're talking about coastal relics. We've found lots of other physics as well. So I'll be making some physics videos and uploading them in the future as I go around. So thank you very much. You just press the cross, camera lady, and that will end the stream.